In this video, we are going to look at the question 9s for the June CSEC math exam for the years 2022 to 2019. So here we have question 9 for June 2022. We have H, J, K, L, and M are points on the circumference of a circle with center O. MK is the diameter of the circle and it is parallel to HJ. So let's see what that is. MK is the diameter of the circle. So you see O here is the center. MK passes through the center, so it's the diameter. And it's parallel to HG. So these arrows here suggesting that these two lines are parallel. We are also saying that MJ is equal to GL. So that's the length of MJ is equal to the length of GL. So this is MJ here, and this is GL here. So this would actually form an isosceles triangle here. And we're saying that angle GMK is 38 degrees. So J to M to K is 38 degrees. Now they want us for part 1 to explain giving a reason why angle HJM is 38 degrees. So let's locate where angle HJM is. So H to J to M. Alright, so here I have it highlighted in blue here. So H to J to M. So they want to know why this angle here is 38 degrees. Now remember this side HG is parallel to the diameter here. And if you look at this, we have a Z, right, with parallel line. So these two angles will be alternate angles. All right, so I just highlighted the Z here so that these two will be alternate angles. That's why this angle is equal to 38 degrees. All right, so for my statement, what I'm going to say is angle HJM is equal to angle JMK. So this is angle JMK here. All right, so angle HJM is equal to angle GMK, which is equal to 38 degrees. And my reason would be alternate angles are equal. So I'll just write alternate angles. Now next, they want us to explain giving a reason why, for part B, angle MJK is equal to 90 degrees. So let's locate that angle. So M to J to K. All right, so that's this angle right here. MJK. That's a right angle. Now, if we notice, this is the diameter here, right? So whatever on this part of the circle will be a semicircle. And we know the angle in a semicircle, meaning once the arms of the angle is standing on the diameter and that angle touches the circumference, that would be a 90-degree angle. And the reason will be angle in a semicircle. Okay, so I just highlighted the diameter and also the arms of the angle. So you can see the arms of the angle standing on the diameter and the angle is at the circumference of the circle. So that's why this angle here is 90 degrees because the angle in a semicircle is a right angle. So I'll have MJK is equal to 90 degrees. I'll just put angle in a semicircle. So moving on to part 2, we want to determine the value of each of the following angles, show detailed working where appropriate. So for part A, we want to do that for angle MLG. So that's M to L to J. So that's this angle down here. Now let's put in the information I had on the previous diagram. All right, so we had this angle here was 38 degrees because that was the alternate angle. And we had here was a 90-degree angle because angle in a semicircle. Now, this angle here stands on the same arc or chord as this angle right here. So I'll just highlight this angle right here. Notice the arms of this angle is standing on this line here, M to J. And the arms of this angle that we want to find standing on the same line, M to J. So these two angles stand on the same chord. Therefore, these two angles are equal. Now, if you look closely, this would form a right angle triangle. So it's possible to find out the value of this angle here at K. So that'll be JKM. Because the sum of the three interior angles of a triangle is equal to 180 degrees. So I'll have 38 degrees plus 90 degrees plus angle MKG is equal to 180 degrees. Now 38 plus 90 is 128. So angle MKG is equal to 180 take away 128. So angle MKG is equal to 52 degrees. And of course, the reason for this is the sum of the interior angles of a triangle is equal to 180 degrees. So I'll just write the reason I decide here. Sum of the interior angles of a triangle is equal to 180 degrees. All right, so that's my reason for this. So I know that here would be 52 degrees. And now that I know that here is 52 degrees, I know here will also be 52 degrees. All right, because these two angles, they stand on the same chord. So that will be angles in the same segment are equal. So now I'll write angle MLG is equal to angle MKG, which is equal to 52 degrees. And my reason would be angles in the same segment. So now moving on to part B of this question, where we want to find out what is angle LGK. So that's L to G to K, so that's the small angle here. Now previously we learned that this angle here was a right angle. We also learned that this angle down here was 52 degrees. And MG was equal in length to GL, so this is an isosceles triangle. So what we know about an isosceles triangle, the base angles of an isosceles triangle are equal. So this whole angle here would be same as this 52 degrees. And therefore, the sum of the interior angles of a triangle would be 180 degrees. So we'll be able to find what this angle is here. That's this angle here. And if we get this angle and subtract it from 90 degrees, we'll get this little piece that remains in here. So I'll put that triangle GML is an isosceles triangle. And the base angles of an isosceles triangle are equal. Hence, angle GLM is equal to angle LMG, which is 52 degrees. All right, so I'm just saying that this angle here is equal to this angle here. All right, and now we can use the sum of the interior angles of a triangle to get this angle up here. So I'm going to put 52 degrees plus 52 degrees plus this angle here, which is MGL. So that's angle MGL is equal to 180 degrees. So 52 plus 52 is 104. So that's 104 degrees plus MGL is equal to 180 degrees. So angle MGL is equal to 180 take away 104. And that's equal to 76 degrees. And of course, the reason for this here is the sum of the interior angles of a triangle is equal to 180 degrees. So now that we know that here is 76 degrees, all we have to do is take away 76 from 90 to get this angle here, which is LGK. Right? L to G to K. So angle LGK is equal to 90 degrees take away 76 degrees. So that's equal to, and that's 14 degrees. And of course, two angles that add up to 90 degrees are called complementary angles. So the reason for this will be complementary angles. So now for part C of this question, I'm going to find angle GHM. So that's G to H to M. So that's this angle right here. Now what we're seeing here is a four-sided shape where all four vertices touch the circumference of a circle. So we call that a cyclic quadrilateral. And remember, we found this angle down here to be 52 degrees. And we know that the opposite angles of a cyclic quadrilateral are supplementary, meaning add up to 180 degrees. So these two will be opposite angles of a cyclic quadrilateral. So I'll have 52 degrees plus angle GHM, will be equal to 180 degrees. So angle JHM is equal to 180 degrees, take away 52 degrees, which is 128 degrees. All right, and as I said, the reason would be the opposite angles of a cyclic quadrilateral are supplementary. So I write for my reason the opposite angles of a cyclic quadrilateral are supplementary. And of course, supplementary meaning two angles adding up to 180 degrees. So moving on to part B now, we have a bearings question. So we have from a port L, so that's L here, ship R is 250 kilometers on a bearing of 65 degrees. So from L, ship R, which is here, is 250 kilometers away on a bearing of 65 degrees. Now we know bearings is a way of giving direction, and bearings are taken in a clockwise direction from the north line. So if you're going in a clockwise direction from the north line, which would be like this will be 65 degrees. And then we have ship T is 180 kilometers from L. So T is 180 kilometers from L on a bearing of 148 degrees. So again, from L, we're going 148 degrees in a clockwise direction to T. So they said this information is illustrated in the diagram below. So for part 1, complete the diagram above by inserting the value of the angle RLT. So that's R to L to T. So that's this angle right in here. That's this angle right here. Now if here to here is 65 and here to here is 148. So if you say 148, take away 65, you'll get this remaining angle here. All right, so for part 1, we're going to have RLT is equal to 148, take away 65. And that will be 83 degrees. All right, so we're going to put 83 degrees here. Now for part 2, they want us to calculate RT, the distance between the two ships. So this is R to T. Now if we look carefully here, we have a non-right angle triangle. All right, we've seen that this 83 degrees is in between the 250 kilometers and the 180 kilometers. So once we have a non-right angle triangle, we know we're either using the sine rule or the cosine rule. And as long as we have an angle in between the two given sides, we know we're looking at the cosine rule. All right, so I'll have to label this triangle with the common letters representing the length of the side, and the capital letters will be the magnitude of the angle. Okay, so let's draw for the triangle here. So we have a simple triangle to work with. So here's L, that's L here. We have the 83 degrees, we have L to R is 250 kilometers, and L to T is 180 kilometers. So now I'll label the length of the side with the common letters. So if here's capital L, which means angle L, then side L, which will be common L, will be here. And that's because, here, let's draw a line from angle L, it will touch this side. So this side is opposite this angle. So that's why you have side L here and angle L here. So angle R is here. If you draw a line from R, it will touch this side. So this 180 kilometers will be side R, common R. And side R is opposite angle R. So same thing here, capital T, angle T. If you draw a line from angle T, it will touch the 250 kilometers. So the 250 kilometers is opposite angle T. So we call that common T. Now, as I said, the angle is in between the two sides that we are given. So that suggests that we're going to use the cosine rule. And seeing that I want to find RT, and that's common L, it means I have to start the cosine rule L and end with capital L. So I'll have common L squared is equal to R squared plus T squared, take away 2 RT cosine angle L. All right, so let's put in the values there now. So we know that side L is RT. So we're going to write RT squared for L. So RT squared, that's for common L. Common R, that is 180 kilometers. So that's 180 squared plus common t squared. Common t is 250 kilometers, so that's 250 squared. Take away 2 times r, and r is 1/8, times t, which is 250, cosine angle L, which is this 83 degrees here. So now RT squared will be equal to, and what we could do is on the calculator, we could put this piece in brackets, and then this piece in brackets here, and the calculator will call this entire thing for us. All right, so I'm going to open the brackets and put the 180 squared plus the 250 squared, close the brackets like that, take away, open brackets, and I'm going to put 2 times 180 times 250 times cosine of 83, close brackets. And of course, make sure your calculator is in degrees because our angle is in degrees. Press equal, and this is our value for RT squared. So that's 83,931, and I'll approximate it to be 0.8. And now RT will just be the square root of that 83,931.8. So RT is equal to, and as I have this answer on the calculator, all I do is press square root and equal, and I will find the square root of the answer, which is 289.7. So that's 289.7 kilometers. So now looking at part 3, we want to determine the bearing of T from R. So that means we have to put the north line on R and take the angle in a clockwise direction from that north line. So I'm going to put a line going straight up the page from R, and that will be my north line. And the angle that we want to find is this angle from the north line in a clockwise direction going all the way around to here. Now let's put in the previous information that we had. So we knew that this angle here was 65 degrees. We knew here was 83 degrees. And the length of the side was 289.7 kilometers. So now looking at the situation here, what I can do is I have all 3 sides on this non-right angle triangle. So I can use the sine rule to find out any missing angle within this non-right angle triangle. Now if I were to extend this north line, come down like this, I would have a straight angle. So from here to here will be 180 degrees. So that's a straight angle here. I'm putting 180. And that's to here. Now bear in mind is the whole angle straight to this line that we want to find. So now we need to find out what is this little piece here. So I put it as this angle here. We want to find out what's this little piece here. What I could do is use the sine rule to find out what is this angle here. All right. And I could split this up as bringing a north line up from T like this. And these 2 north lines will be parallel to each other. So we have a Z here. So we have alternate angles. So this little piece here will be equal to this little piece here. Now bear in mind, I'm using the sine rule to find out what is this whole angle here at T. And what I could do is extend this north line here at L. And this angle here in green will be equal to this angle here. Again, you'll have the Z. So this north line will be parallel with this north line here. And we have alternate angles again. We've seen the Z here. Alternate angles are equal. So these 2 angles here are equal. All right, so I just highlighted the Z here for the alternate angles. And then I highlight this Z here for the alternate angles as well. Now, this here will form a straight angle. So we just have to add up 83 and 65 and take it away from 180 to get this little piece here, which will then give us this little piece here. So we'll have 180 degrees, take away 65 plus 83, and that'll be equal to, so I'll just put 180, take away open brackets, 65 plus 83, close brackets, and that's 32 degrees. All right, so I'm going to get 32 degrees here. So it means here is 32 degrees. So that means here is 32 degrees. Alternate angles are equal. All right, so I just drew back my non-right angle triangle, which represents this here to work with. And of course, we want to find this angle down here at T. All right, so we want to find this angle here. So we just label back this triangle with common letters to represent the length of the sides. So if capital T is here, common T is here. If capital R is here, opposite to that, here will be common R. Of course, if capital L is here, then common L will be here. So I said we have all three sides. We can use the sine rule to find any angle we want. We could also use the cosine rule to find any angle we want. But it'll be easier to use the sine rule. All right, so seeing that I know what is angle L and side L, I'll set up the sine rule like this. I'll have common L over sine capital L is equal to, and I'll see that I want to find angle T, and I know side T, so I'll have common T over sine capital T. Now, the reason I use this common L over sine capital L is because in any equation, we only allowed one unknown. I know what common L is, that's just 289.7, and I know what capital L is, which is A3. So I know the values for common L and capital L. Now, seeing that I want to find capital T, that's my unknown. So that's my only unknown, and I know what is side T. So I know what is this common T, and this capital T is the only unknown. So that's why this works. So now putting in values, common L is 289.7 over sine capital L, which is 83 degrees. And that's equal to common T, which is 250, over sine capital T, which is what we want to find. All right, so what I'll do now is cross multiply. So I'll multiply this 289.7 by the sine capital T. And that will give me 289.7 sine capital T. And then I'll multiply the sine A3 by 250. And that will give me 250 sine A3 degrees. So now I'll transfer this 289.7 across the equal sign, and the operation between this 289.7 and sine T is multiplication. So when this 289.7 goes across, the operation will change to division. So I'll have sine capital T is equal to 250 sine A3 degrees divided by 289.7. So sine capital T is equal to, so I'll go on my calculator and open brackets and put 250 sine A3, close brackets, and then put divided by 289.7. And I'll get this decimal here, 0.8565. So I'll write this as 3 significant figures. So 0.856, stop here. After is a 5, so this will go up by 1, so 0.857. So I have 0.857. So now capital T would be the sine inverse of this 0.857. So capital T is equal to, so I'll press second function and sine to get sine inverse, and then I'll put 0.857. Press equal, and that's 58.98 degrees. So I can round that off to 59 degrees. So that's 59 degrees. So now knowing the angle at T is 59 degrees, that's this whole thing here is 59 degrees, then this little piece is, well, 59 take away 32. All right, so now 59 degrees take away 32 degrees is equal to 27 degrees. So that means here is 27 degrees, which means here is 27 degrees. So now the bearing of T from R is this whole angle, which will be the 180 plus the 27. So the bearing of T from R is equal to 180 plus 27, which is equal to 207 degrees. All right, so moving on to question 9 for June 2021, we have part A in the diagram below. E, C, G, and F are points on the circumference of a circle. EG is the diameter of the circle, so that's E to G here, see past the center, that's the diameter. The tangent AEB is parallel to CD, So this is the CD here, and this is the AEB. So these two lines are parallel. You can see the arrow on both of them, suggesting that these two lines are parallel. And we have angle AEC is 60 degrees. So that's AEC 68 degrees, and angle EFD is 106. So that's angle EFD is equal to 106 degrees. So first question, we want to determine the value of each of the following angles, show detailed working where necessary, and give a reason to support your answer. So first question, we're going to find what's angle ECD. So that's E to C to D. That's this angle right here. Now, if you look carefully, we have parallel lines, and anytime we have parallel lines, look out for alternate or corresponding angles. Okay, and we can clearly see we have our parallel lines here, and we have this Z being formed here. So these two angles, they are alternate, so they are equal to each other. So for part 1, we'll have angle ECD is equal to angle CEA, which is 68 degrees. And my reason, alternate angles. All right, so here is 68 degrees. All right, so moving on to part 2 now, we're going to find, of course, given reasons for answers as well, angle CEG. So that's C to E to G. So that's this angle right here. Now, as we know, the angle between the radius, so from O to the circumference will be the radius, and a tangent is a right angle. All right, so this is my right angle here. So 68 degrees plus whatever angle this is must add up to be this right angle. So these two angles will be complementary angles. But first, I'll have to write my reason for this. And this is angle GEA. So I'll say angle GEA is equal to 90 degrees. And that's because the angle between the radius and the tangent is a right angle. So now angle CEG plus the 68 degrees must be equal to the 90 degrees, all right, because they are complementary angles. So angle CEG is equal to 90 degrees, take away 68 degrees. So angle CEG is equal to 22 degrees. And I'll just put complementary angles as my reason. All right, so moving on to part 3, we want to find out what is angle CGF. So that's C to G to F. So that's this angle on top here, CGF. Now just go back here to see the angles that I've found previously, the 68 and the 22. So let's put those in, 68 degrees and 22 degrees. Now what I noticed, this is a straight line here. So 180 take away 106 will give us this little piece of angle here. So this angle is E to F to C. Right, so angle EFC is equal to 180 take away 106, which is equal to 74 degrees. And my reason for that is a straight angle. All right, so here's 74 degrees. And now I'm looking at my parallel lines again, and I can see my Z here. So that here will also be 74 degrees because alternate angles. So this is angle BEF. So angle BEF is equal to 74 degrees. Alternate angles are equal. So let's write alternate angles. And now these four angles here, 68, 22, and this missing piece here, and this 74 will be a straight angle. So this missing piece would be, let's put this in red here. This would be angle FEG. All right, so angle FEG is equal to 180 take away 68 plus 22 plus 74. So that's equal to, all right, we have 180 take away, open brackets, 68 plus 22 plus 74, close brackets, and that's 16 degrees. All right, so we got 16 degrees here. So this is 16 degrees here. Now, why did I do that? Well, I'm seeing that we have a cyclic quadrilateral here. Let's highlight that. All right, and I know that the opposite angles of a cyclic quadrilateral are supplementary. So this 22 plus 16 will be the opposite angle to this angle CGF. And these two angles will have to add up to 180 degrees. So what I could do is just say angle CGF plus the 22 plus the 16, right, must add up to 180 degrees, and that's because the opposite angles of a cyclic quadrilateral are supplementary. All right, so angle CGF, 22 plus 16 is 38. All right, is equal to 180. Carry across the 38. So that's 180, take away 38. So angle CGF is equal to 142 degrees. So I'm going to write up here 142 degrees. And of course, the reason for doing this is that the opposite angles of a cyclic quadrilateral, this whole angle here is opposite to this one here. This is a four-sided shape. All four vertices touching the circumference of the circle. So it's a cyclic quadrilateral. And the opposite angles are supplementary. So I'm going to put the opposite angles of a cyclic quadrilateral are supplementary. All right, so moving on to part B now, which is the bearings question. We have from harbor H, the bearing of two ships, Q and R, are 69 degrees and 151 degrees respectively. So from harbor H, so that right, north line is on H, whatever you're taking the bearings from, that's where you're going to put the north line. We have the bearing of Q is 69 degrees, so that's why 69 degrees is here from this line, from the north line connecting to this line with the Q here. And the 151, that'll be from the north line to the one connecting with R. So let's just put that in. So from here to here is the 151. So that's the 151. So just remember, bearings are always taken in a clockwise direction from the north line. And we are taking the bearings from H. So that's why the north line is on H and going in a clockwise direction like this. Now we're saying that Q is 175 kilometers from H. So Q to H is 175 kilometers. All right, so that's 175 kilometers. While R is 242 kilometers from H. So we have R is 242 kilometers from H. So that's one to put into the diagram. So part 1, copy the diagram above to show the information given. Well, we did that. We put in the 175 kilometers, which is from H to Q. And we put in the bearing of 151 degrees, which is the bearing of R from H. Now part 2, we want to calculate QR. That's Q to R here, the distance between two ships to the nearest kilometer. Now we subtract the 69 from the 151 to get this angle inside of here. So that's going to put here 151 degrees, take away 69 degrees is equal to, and that's 82 degrees. So that means inside of here is 82 degrees. So this is a non-right angle triangle, which means we're using sine rule or a cosine rule to find this missing side. So let's see what we are given. We have these two sides, and we have this angle in between the two sides that are given. Anytime we see that pattern, we know we're going to use the cosine rule to find this missing side here. All right, so basically, if this is capital H, then out here is common H. This is capital Q, then here is common Q. Opposite to Q, if you draw a line, touches here, common Q, right? Opposite to capital H, if you draw a line, touches here. Capital R is here. If you draw a line, we'll touch this side, which means this is common R. And now see that we want to find QR. So this is for part 2. All right, that's common H. So we're going to have H squared is equal to your other two sides is R and Q. So R squared plus Q squared. Take away 2 times RQ cosine capital H. All right, so H squared, that'll be RQ squared. Okay, R is 175, so that's 175 squared plus Q squared. Q is 242. So squaring that, take away 2 times r, which is 175, times q, which is 242, cosine capital H, and angle H is 82 degrees. Now, we can put all this into the calculator. Let's put brackets here and brackets here. All right, so we're going to have RQ squared is equal to, let's get the calculator up. All right, so we're going to open brackets, put the 175 squared plus the 242 squared, close the brackets, take away, open brackets, 2 times 175 times 242 times cosine 82. All right, and close brackets, and that gives us 77,401. Now, writing this to the nearest kilometer, so I'll just take some decimal places before my final answer. So I'll write 77,401.03, and since after 3 is 8, I'll put this up by 1 and put 4. So 77,401.04. So now RQ will be square root of 77,401.04. Now, once I have the answer still on the calculator, I can just press square root and press equal, and we'll find the square root of the answer. So it takes the whole answer with all the decimal places into consideration, and we get 278.2. We're writing this to the nearest kilometer, so that's 278, because after the 8 is a 2, so the 8 remain the same. So RQ is equal to 278 kilometers. So moving on to part 3, we want to calculate how far due south is ship R from the harbor H. So this is the harbor H and this is ship R. Now let's say how far due south. So I'm just going to draw a straight line across from R like this. And I'm going to bring a line straight down like this to touch. Let's erase this excess piece here. All right, so if going up is north, then going straight down would be south. All right, this is south. So this is a north line going up the page, and going down the page, this is a south line. So what you'll have forming here would be a right angle triangle. So it's going to put in the right angle here. All right, so this is a right angle triangle. This 242 will be hypotenuse of the right angle triangle. And what we want to find is this side here. All right, so if you recall, here was 82 degrees. And therefore, this being a straight line, which would be a straight angle, 180 degrees, we could add up the 82 and the 69 and subtract it from 180, and we get this angle here. All right, so 180 degrees take away 69 plus 82 is equal to, all right, so we have 180 take away, open brackets, 69 plus 82. Close brackets, and we get 29. All right, so this is 29 degrees here. So that means this angle here is 29 degrees. All right, so basically this is the right angle triangle that we have, the 29 degrees here, the 242 kilometers, and your right angle. So now we know the side opposite the right angle will be the hypotenuse. So the side opposite the right angle, that will be our hypotenuse. This is the angle that we have. So the side opposite to that would be called the opposite side. So you call that the opposite. And of course, the next side will be the adjacent side. Now, seeing that we want to find out how far due south ship R is from H, we want to find the adjacent side. So using my trig ratios, because we have a right angle triangle, my ratio must have adjacent in it. So that will be my only unknown. I know my angle. So whatever I choose as my next side, I must know the value of it. So I can't use opposite because that's also unknown. So I'll have to use the hypotenuse, because I know the length of the hypotenuse is 242 kilometers. So I'll say so ka toi, and I'll see which trig ratio has both adjacent and hypotenuse. And that'll be ka, so using cosine. So I'm writing cosine, my angle is the adjacent over the hypotenuse. So cosine 29 degrees, because that's my angle that's given, is equal to my adjacent, which is the side that we want to find, over the hypotenuse, which is 242. So what I'll do, I'll just put this over 1 so I can cross multiply the cosine 29. So when I multiply 1 times the adjacent, I'll just get back the adjacent side. And cosine 29 degrees by 242, I'll get 242 cosine 29. All right, so my adjacent side will be equal to, all right, so let's type in 242 cosine 29 on the calculator, press equal, and I have 211.6. All right, so we'll write this to the nearest kilometer, so that'll be 212, because after the 1 here is a 6, so this one will go up by 1, which will be 2. So 212 kilometers. So that's 212 kilometers. So now I'll write ship R is 212 kilometers due south of Harbor H. So now moving on to question 9 for June 2019. This is the circle geometry. So we have the diagram below shows a circle where AC is the diameter. So A to C passing through the center of the circle. So that's the diameter. B and D are two other points on the circle. So we have B and D. And angle DCE is a straight line. So this is a straight line coming out here from D to E. So we have angle CAB is 28 degrees. So that's this angle here. C to A to B, 28. And angle DBC is 46. So angle D to B to C is 46. Now they want us to calculate the value of each of the following angles. Show detailed working when necessary and give a reason to support your answer. So for part 1, we want to find out what is angle DBA. So that's D to B to A. That's this angle right here. Now what I'm seeing here is from A to C is the diameter. So this portion here is the semicircle. This angle at B touches the circumference of the circle, and the arms of the angle are on the diameter. So this will be our right angle here. All right, so I'm putting this right angle here. So let's write down that. Angle ABC is equal to 90 degrees. Right, I'm going to put angle in a semicircle. So now this 46 degrees and angle DBA are complementary angles, meaning they add up to 90 degrees. So angle DBA is equal to 90 take away 46. And that'll be equal to 44 degrees. My reason for that would be complementary angles. So again, complementary angles are angles that add up to 90 degrees. All right, so let's put my answer here as 44 degrees. Now for part 2, we're going to find angle DAC. So that's D to A to C. So that's this angle right here. So now if you notice this chord here, D to C, we have the arms of this angle DAC, D to A to C, and also the arms of the angle from C to B to D. Right? They both standing on the same chord. Therefore, we call that angles in the same segments are equal. So if here's 46, then here will also be 46. See the arms of this angle stand on the chord DC. The arms of this angle stand on the same chord DC. So these two are equal angles in the same segment. So angle DAC is equal to angle DBA, which is equal to 46 degrees. Reason? Angles in the same segment. All right, so now moving on to part 3, we're going to find out what's angle BCE. Of course, given reasons for the answers. So that's B to C to E. So that's this angle out here. Now, before I can get this angle BCE here, I'd like to find out what is angle DCB. There's this whole angle here. So just looking at this diagram, the chord BC, I'm seeing that this angle at A here, the arms of the angle stands on the chord BC, and also the angle at D, the arms of the angle stands on the same chord BC. So these two angles are equal. So if here's 28, then here's also 28. So I'm going to write angle BDC is equal to angle CAB, which is 28 degrees. And that'll be angles in the same segment. Next, I'll recognize that this here is a triangle. All right, so I want to find this angle here on the triangle. Let's put that here, and this is the angle that I want to find. All right, I know some of the interior angles of a triangle must add up to 180 degrees. So I know 28 plus 46 plus this angle here, which is BCD, must add up to 180 degrees. So I know that 28 degrees plus 46 degrees plus angle BCD must add up to 180 degrees because some of the interior angles of a triangle is equal to 180 degrees. All right, so 28 plus 46 is 74. So 74 degrees plus BCD is equal to 180. So angle BCD is equal to 180 take away 74. So angle BCD is equal to 106 degrees. So that means this angle here is 106 degrees. And of course, my reason will be sum of the interior angles of a triangle is equal to 180 degrees. So now here we have a straight line, which is a straight angle. So 106 plus this angle here in green, which is angle BCE, would be equal to 180 degrees. So angle BCE, which is what they want us to find, is equal to 180 take away 106, which is equal to 74 degrees. And my reason would just be a straight angle. What I could have also done is say that this is the exterior angle for this triangle here, and the exterior angle is equal to the sum of the two interior opposite angles. Could have also used that reason as well. So after finding out that here is 28 degrees, I didn't need to find this 106 degrees. All I have to say is this exterior angle is equal to the sum of the two interior opposite angles. So angle BCE is equal to the 28 plus 46. All right, so moving on to part B, we have the diagram below shows a quadrilateral PQRS. So this is a quadrilateral here, PQRS, where PQ and SR are parallel. So P to Q and S to R are parallel. So let's put in the arrows one time. All right, so that will mean that this is a trapezium. We have SQ is equal to 8 centimeters. So S to Q, there's 8 centimeters here. We have angle SPQ is 90 degrees. So S to P to Q, 90 degrees. Angle SQR is 82 degrees. So S to Q to R, that's 82 degrees. And we have angle QSR is 30 degrees. So Q to S to R is 30 degrees. Now, first we want us to determine the length of PS. So this is PS here. We can see that this is a right angle triangle here. Parallel lines, look for alternate or corresponding angles. So we can see a Z here. So if here's 30 degrees, then here's also 30 degrees. Alternate angles. So now I'll take out my right angle triangle. All right, putting it 30 degrees here. Here will be 8 centimeters. Here will be my right angle. This will be P, this will be Q, and this will be S. So now I'll label the sides of this right angle triangle. Opposite the right angle is the hypotenuse. So this here is the hypotenuse. opposite the angle that's given, or the angle that I want to find, is the opposite side. So if you draw a line from this, it'll touch this side, so that's the opposite. And of course, the next side is the adjacent side. All right, so seeing that we want to find PS, or trig ratio, must have opposite in it. And the only other side that we are given is the hypotenuse, so a trig ratio must have hypotenuse in it as well. So which trig ratio is opposite and hypotenuse? They say so car toi, and that'll be so, SOH, right? Sine is opposite over hypotenuse. All right, so let's remember it's so car toi, and you're looking to see which trig ratio has opposite and hypotenuse, O and H. So that'll be so here, right? O and H. Sine is opposite over hypotenuse. And the reason for going with sine is because you only allowed one unknown, and the unknown is the opposite side, and that's what you want to find. So that's why this must be included in your ratio. Everything else you must know. So you know the angle, and you know the other side. That's why I couldn't use the adjacent side, because I don't know the length of the adjacent. And if you had used the adjacent side, you'd have two unknowns, opposite and adjacent are the two unknowns. And you can't solve an equation with two unknowns unless it's simultaneous equations. All right, so I'm going to have sine my angle is equal to the opposites over the hypotenuse. So sine 30 degrees is equal to the opposite, which is PS, over the hypotenuse, which is 8. So let's set this up for cross multiplication. So I'll say 1 by PS will give you back PS. And sine 30 by 8 will give us 8 times sine 30 degrees. So PS is equal to, all right, we just type on our calculator, 8 sine 30, and we get 4. All right, so that's 4 centimeters. All right, so let's put in this length here as 4 centimeters. All right, so moving on to part 2, we want to find the length of PQ. So that's P to Q. So now we can use the same right angle triangle because we'll have two sides and one missing, which means we can use Pythagoras' theorem to find the missing side. All right, so here I've drawn over my right angle triangle. So we're going to find this missing side here, PQ. And as I said, it's a right angle triangle. We have two sides and one missing, so that means we can use Pythagoras' theorem. So Pythagoras' theorem states that the square on the hypotenuse is equal to the sum of the squares of the other two sides. So that means we have to put the square on the hypotenuse first, which is, as you know, opposite the right angle is the hypotenuse. So this 8 centimeters is the hypotenuse. So what we're going to have is 8 squared first is equal to the sum of the squares of the other two sides, which will be the 4 and the PQ. So I'll have PQ squared plus 4 squared. So I'll carry across the positive 4 squared, and I'll have 8 squared take away 4 squared is equal to PQ squared. And our PQ will be square root of 8 squared take away 4 squared. So PQ will be equal to, all right, I'll just go on my calculator and press the square root button, open brackets, press 8, press the x squared button, take away 4, press the x squared button, and make sure and close brackets. And I'll get 6.928. So I'll write out the three significant figures as 6.92. After the 2's are 8, so this will go by 1, so 6.93. So that's 6.93 centimeters. Now for part 3, they want us to find the area of PQRS. So that's the whole quadrilateral, P to Q to R to S. And now, as we said, this is a trapezium, and the area of a trapezium is a half the sum of the two parallel sides multiplied by the height. And the height is always at 90 degrees to the parallel sides. So 4 centimeters is the height. We just found PQ is 6.93. So that's 6.93 centimeters here. So the only thing missing now to find the area of this trapezium was the length of SR. So we could use this non-right angle triangle. So here I just drew for the non-right angle triangle, Q to S to R. So what we'll do is label it with the common letters to represent the length size sides. So if this is capital R here, common R is 8 centimeters. So that's common R. if this is capital Q here, then common Q is down here, opposite. So that's common Q. And if there's capital S here, then opposite to that will be common S. Now notice we don't have two sides given and an angle in between, so cosine rule is out. So we're looking at sine rule. Okay, so see now we want to find length of SR. We'll be using Q over sine Q. So that'll be Q over sine Q is equal to, now we already have our one unknown, which is common Q. We know what is capital Q. So whatever we use next here, we must know both the side and the angle. And I've seen that I can't find that requirement because I know side R, but I don't know angle R. I'll have to actually go and find what angle R is, which is basically adding up 82 and 30 and taking away from 180. All right, so angle R is equal to 180 take away 82 plus 30 degrees. All right, so let's have 180 take away open brackets 82 plus 30 degrees close brackets, and that's 68 degrees. All right, so angle R is 68 degrees, so that means here is 68 degrees. So now I could say R over sine capital R because I know common R and know what is capital R. All right, common R is 8, capital R is 68 now. Okay, so time to put in the values. So for Q, I'll put that as SR. For sine capital Q is 82. And that's equal to common R, which is 8, over sine capital R, which is 68. So now I'll cross multiply. So I'll say SR by sine 68. So that's SR sine 68 degrees. And I'll say sine 82 times 8, which is 8 sine 82 degrees. So now seeing that the SR is being multiplied by sine 68, when I transfer sine 68 across the equal sign, the operation changes from multiplication to division. So I'll have SR is equal to 8 sine 82 divided by sine 68 degrees. So SR is equal to, open brackets, 8 sine 82, close brackets, divided by sine 68. And that's equal to 8.54, the three significant figures. 8.54 centimeters. All right, so now that we know the length of SR, which is the 8.54 centimeters, we have the length side, two parallel sides, and we have the height. So we're going to have the area of the quadrilateral, PQRS, which is a trapezium, is equal to half the sum of the two parallel sides, and that will be 6.93 plus 8.54 multiplied by the height, which is 4. So that'll be equal to, so let's put that in calculator. So a half is 1 over 2, open brackets, sum of the two parallel sides, that's 6.93 plus 8.54, close brackets, and then you're going to multiply that by 4. And you'll get to the 0.94. So the three significant figures, that's just to the 0.9 centimeters squared. And that's it for this video.